Good afternoon, all of you. In this chapter, redox reactions, we were discussing about balancing of redox reactions. So in that, we completed the oxidation number method. Both acidic and basic mediums we completed. Now we are moving on to the next part, which is half reaction method to balance redox reactions. It is somewhat similar to that of oxidation number method only. Slight changes are there. We will see that now. So half reaction method. In this, two half equations are balanced separately and then added together to give a balanced equation. In the oxidation number method, what we have done is we just considered the whole equation and we balanced it by adding whatever is needed in the both sides. In this, we will separate the whole reaction into two parts, which is the reduction part and the oxidation part, and we will balance both of them, and finally we will add them together to get our net equation. That's what a half reaction method is all about. And we will discuss an example. Similar to that of oxidation number method, we can do this method also in two mediums, which are acidic medium and basic medium. So today we will be discussing about the acidic medium reaction. So this is the example we have taken here. Fe2 plus Cr2O7 2 minus gives Fe3 plus Cr3 plus. So this is an unbalanced equation and we are going to balance it. So as I told, it is very similar to that of oxidation number method. So in the step 1, we will be finding the oxidation numbers and we will be finding which one is oxidized and which one is reduced. So Fe2 plus, as a single atomic ion, Fe2 plus, we don't have to find any other numbers. So 2 plus is only in its oxidation state. So as it is a single atomic ion, we don't need to consider any other numbers. So whatever is the charge there, that only is the oxidation number. So Fe is having an oxidation number of 2 plus here. And in Cr2O7 2 minus, so 2 minus is the net charge there. So oxygen will have 2 negative charge. So 7 into 2 negative, it will be 14 negative. So to balance that 14 negative and get a net charge of 2 minus, how much Cr2 plus should need? So Cr2 should need as 12 plus. 12 plus minus 14 will become 2 minus. So 12 plus is the charge of Cr2. Hence 1 chromium will have a charge of 6 plus. So here 7 into 2, 14 minus is there for oxygen. So to balance that 14 negative and to get net charge of 2 plus, Cr2 needs 12 plus. So 12 plus minus 14, 12 minus 14 becomes minus 2. So Cr2, 2 of the chromiums give 12. So 1 chromium will have 6 plus charge, or 6 plus is the oxidation number of chromium here. And in this case, Fe is converted to 3 plus. And in chromium also it is converted to 3 plus. So how the oxidation and reduction is? Oxidation and reduction will be like Fe2 plus, from 2 plus it is converted to 3 plus. So from 2 plus to 3 plus it is an increase in oxidation state. Increase in oxidation state means oxidation. In chromium 6 plus to 3 plus. So decrease in oxidation state, which is reduction. So chromium is getting reduced by 3 electrons and iron is getting oxidized by 1 electron. So this is the first step of considering in acidic medium of half reaction method. Moving on to the next step. So step 2, here is the change from oxidation number method. Here we are separating the equation to two half reactions. The oxidation reaction and reduction reaction we are separating into two different reactions. So oxidation half will be Fe2 plus gives Fe3 plus. So Fe2 plus oxidized to Fe3 plus. That is the oxidation part. And the reduction half will be Cr2O7 2 minus to Cr3 plus. So that there the reduction occurs and hence we can tell this is the reduction part. So we separated the whole equation to oxidation half and reduction half. Now we need to balance the oxidation half and reduction half separately. For that, we are moving on to the third step. Balance the atoms other than oxygen and hydrogen. So that's what we are going to do in the third step. This is somewhat similar to that of oxidation number we have done. So the oxidation half, it is actually balanced. Fe, one atom is there. In this side also, one atom is there. There is no change for that. In the reduction half, Cr2O7 2- gives Cr3 plus. Here, in this side, we have Cr2. In this place, we have just one atom of chromium. So it is not balanced, and we don't need to consider oxygen because in this step, we are balancing atoms other than oxygen and hydrogen. So we don't have to check oxygen and hydrogen here. So leaving the oxygen, chromium is not balanced here. Here we have two atoms, and in this place we have just one atom. So we need to add, we never reduce atoms in a reaction, we always multiply. So that to make the same number of chromium both the sides, we are adding a 2 to this side. So now it is balanced. Oxidation half was actually balanced, and reduction half also we balanced now. That's what the third step is all about. Now moving on to the fourth step, where we balance this oxygen and hydrogen. So in this step, we are balancing oxygen and hydrogen. Oxygen by adding H2O to it. How much ever oxygen is remaining or deficient, that much of H2O we can add there. Or how much ever hydrogen atoms we need, the same number of H plus ions we can add to any of the sides. So this is what we do in acidic medium, and the same step we have done in the previous method also, but the only difference is here we are considering just the half reaction. The balancing is done to the half reaction. Then finally we will sum it. So the reduction part Cr2O7 2- gives 2Cr3 plus. Here we are going to balance the number of oxygen and number of hydrogens. So there is no hydrogen now, so we don't have to balance it. First we are balancing oxygen. Here we have 7 oxygens, and this side we don't have any number of oxygen. So that we are going to balance by adding H2O atoms to this side. So here we have 7 oxygens. So to balance that, we are adding 7 H2O to this side. So now the number of oxygen atoms is balanced. Now we will see about hydrogen atoms. How many hydrogens we need to balance? Here we have 14 hydrogens, and here we don't have any number of hydrogens. So the same thing which we have done in the previous method, we are adding same number of H plus ion to this side. So now the number of hydrogens and oxygen is balanced here. And now we will see the oxidation half, which is Fe2 plus and Fe3 plus. Here we don't need to do anything because there is no hydrogen or oxygen present, so we don't have to balance it at all. So we balance the number of oxygen and hydrogen atoms here. Now what we need to do is balance the number of charges in both the reactions, or in oxidation and reduction part, we need to balance the number of charges. So the next step, step 5, add electrons to half reactions to balance the charges. So we will see the first reaction. Cr2O7 2- 14H plus gives Cr3 plus H2O. So this is the reduction part, and in reduction part we need to check whether the charges in both the sides are equal or not. So here we have 14H plus, so 14 positive charges plus 1 2-. So totally it will become 12 plus charge. So 2 negative charges from this and 14 positive charges from this. So hence totally we have 12 positive charges. And in this place if you see 3 into 2, 6 positive charges are there, and in this there is no charge. So 2 into 3, 3 twos are 6 positive charges are there. So 12 charges this side and 6 positive charges this side. So we need to balance this by adding electrons. So electrons are negative in charge. So how much ever we add electrons, the positive charge will reduce. The same we are doing here. If we add 6 electrons to this side, the 12 charge will become 6 plus. So in both the sides we will get 6 plus. So once we are adding 6 electrons, the 12 positive will change to 6 plus as we are adding negative charge. So 12 minus 6, 6 positive charge will be there in this side, and even here we will have 6 positive. So the charges are balanced. In the next reaction, which is the oxidation half, Fe2 plus to Fe3 plus. In one side we have 2 plus, another side we have 3 plus. So to balance this side we need to add just 1 electron. So by adding 1 electron, the 3 plus will reduce to 2 plus. There is no change in this ion, but in this part of the product part, the total charge will become 3 plus. And in here, it remains as 2 plus. So both the sides, the total charge or the net charge becomes 2 plus. So hence, this is also balanced. Now we have one more problem. So in this the reduction part, we have 6 electrons. And in this, we have just 1 electron. So we need to balance this also. And for that, what we does is, we multiply the whole equation with 6. So 6 plus into the whole equation, that becomes 6 Fe2 plus gives 6 Fe3 plus 6 electrons. So the number of electrons in the oxidation part will be equal to the number of electrons in the reduction part. So that also we balanced. So for that what we did, we multiplied the whole equation with a number so that all of them will be multiplied with the same number, and finally the electrons also. So the number of electrons are balanced. In the next step, what we are doing is add the two half reactions to achieve the overall reaction. So now we have with us the balanced reduction part and the balanced oxidation part. Both of them are balanced. Once we achieve this stage, what we need to do is we need to add both the reactions. So we are taking the sum of both reactions to get our overall reaction. Here what we does is we add the reactant part to get the reactant equation, and we add the product part to get the product equation. So we can cancel off the electrons also. So in this reaction, if you see, in the reactant part we have 6 electrons. Same number of electrons are there in the product part in next equation. In this equation, 6 electrons are there in the reactant part. And in next equation, same number of electrons are there in the product part. If this is the case, we can cancel off both the electrons. So both the electrons are cancelled here. Hence, the sum will become the reactant part we will get from adding the reactant parts, and product part we will get by adding the product parts. So here we are adding 6 Fe2 plus from this reaction, Cr2O7 2 minus and 14H plus from this reaction, and 6 Fe3 plus from this part, and Cr3 plus plus H2O from this part. So both the reactions are added together to get our final overall equation. So this is our balanced redox equation. So after 6 steps, we got our balanced equation by half reaction method. So using the same method, you need to calculate this also. Write this as a balanced equation by using half reaction method and even the acidic medium. So do this and submit. Thank you.